Jai Hind everyone. I am Shruti Jain, Assistant Professor, MCA Department, Ajay Kumar Garg Engineering College, Ghaziabad. The topic that I am going to discuss today is software quality assurance. This topic is covered under the subject BMC 302 and the subject name is software engineering. The target students over here are MCA second year, third semester students. So when we are talking about the software quality assurance, let's understand first what quality is. So when we talk about a quality, it simply means that a product should meet its specifications. Whatever is being decided for a particular software to do, all those things are being done by the software that gives us a qualitative software. Now, this is problematic for software systems because there is a tension between the customer quality requirements, that is the efficiency, the reliability of the system, and the developers quality requirements, which mainly focuses on the maintainability, the reusability, etc. So when we talk about the customer quality requirements, they are totally different, or they might be different from the developers requirement, because when the customer talk about the quality requirements, they want the system to be easy to understand, easy handling of the system. It should be reliable enough that they can work upon it for long number of years. It should give them the expected output or accurate output. But when we talk about developers, their quality requirements could be that the system should be maintainable at the later stages. It could be reused. The components are made in such a manner that they can be reused in further softwares, or maybe in the same software if they want, or the extensibility of the software, or they might be talking about the portability of the software. So these are some of the requirements which could be different from the customer and the developer. Some quality requirements, they are difficult to specify unambiguously, because sometimes it happens that they come up with such quality requirements which are not very, which can be handled properly. The software specifications are usually incomplete or often inconsistent. So if we talk about the IEEE standard glossary, the definition of software quality, it says that it is a degree to which a system, component or a process meet the specified requirements, customer or user needs or their expectations. So that is software quality. It is commonly recognized as the lack of bugs in the program, because we say if a software does not give you any error or it does not crash when you are working on a large number of data, then your software is a qualitative software. It is not having any errors, any bugs, then it is a qualitative software. If the software has too many defects, it does not meet its basic functionality requirements, and hence it is not a qualitative software. Now this is usually expressed in two ways: the defect rate and the reliability. The defect rate is basically the number of defects that are there per million lines of source code. That is the defect rate. Now when we talk about the reliability, it is generally measured as the number of failures per T hours of operation. At every T hours of operation, they try to identify the number of failures. If the failures are more, then we say that that needs to be checked. If the failures are less, then also a need for the check is there, but still the software is a qualitative software. So it is a mean time to failure, or the probability of a failure-free operation in a specified time under a specified environment. So we have some of the attributes that we'll be discussing today. We have 4 domains of it, or maybe 4 domains of it, where we talk about the reliability, the usability, maintainability, and the adaptability attributes. When we talk about the reliability attribute, we have certain attributes in it: the correctness, consistency and precision, the robustness of your software, the simplicity and the traceability of the software. When we talk about the usability, we again have some of the attributes in it, which says the accuracy, clarity and accuracy of the documentation, conformity of the operational environment, the completeness, efficiency, and the testability. Similarly, when we talk about the maintainability, the attributes that we have are accuracy and clarity of the documentation, the modularity, readability, and simplicity. Talking about the adaptability, we have 3, where it talks about the modifiability, expandability, and the portability of the system. So these 4 are the major domains that we talk about, and all these are the attributes that come under these domains. Now let's understand these attributes one by one. So when we talk about reliability, reliability is basically the extent to which your software is performing some of the function that is given to the software without any failure. That means the software is reliable enough to give you the expected output. Correctness, the extent to which your software is meeting its specifications, that means it is performing as per the user's demand. Consistency and precision, it says that it is an extent to which a software is consistent and gives you the result with precision, very accurately. Whatever output that you want is given to you in the same manner, and the software is consistently working. It is not the case that at one point of time it is giving you one output and the other point of time it is giving some other output. Robustness, the extent to which a software tolerates the unexpected problem in case any bug occurs or any error occurs. Is your software robust enough that it does not crash or it does not behave abnormally? So that comes under the robustness. Simplicity, the extent to which a software is simple enough that it is easily understandable by any of the user. Traceability, the extent to which an error is traceable. You can identify the error easily whenever you want to fix a particular error. Usability, the extent of effort that is required to learn, operate, and understand the functionality of the software. Again, this usability talks about the simplicity, because if your software is simple, it is easy to learn, operate, and understand the functionality of the software. Accuracy, meeting the specification with precision. It should be accurate that what the user wants, it is getting that. Clarity and accuracy of documentation. Now here they are talking about the documentation part as well, where the documents are clearly and accurately written. Conformity of the operational environment, the extent to which a software is in conformity of the software talks about that yes, it is working properly into this operational environment. Completeness, the extent to which a software has some specified functions. Efficiency, the amount of computing the resources and code that is required by the software to perform any of the function, that is efficiency. Testability, the effort that is required to test a software to ensure that it performs its intended functions. So testability means that when you are testing a software, in that case again there are some of the efforts required. So they believe that the less the efforts that are being made when you are testing a software, your software is a qualitative software. Maintainability, the effort required to locate and fix an error during the maintenance phase, or it is not only related to fixing the errors, it could be enhancing the capabilities of the system. Modularity, it is the extent of ease to implement, test, debug, and maintain the software. So when you are making proper modules of your system, it is easy to implement and test or debug the software. Readability, the extent to which a software is readable in order to understand, and then it can be understood by the user as well as the developers in the future times. Adaptability, the extent to which a software is adaptable to new platforms and technologies. Modifiability, the effort that is required to modify a software during the maintenance phase, that is, so here when we were talking about the maintainability, we were talking about locating and fixing the errors. Again, coming to the maintenance phase, when we are talking about the modification of the software, that is either adding new functionalities or deleting the obsolete functionalities that are there in the system which the user now currently does not want, then we call it as modifiability. Expandability, the extent to which a software is expandable without undesired side effects, which is again a part of the maintenance phase. Portability, the effort required to transfer a program from one platform to another. So, all these attributes that we have studied till now that can be understood when we are talking about the McCall software quality model. Now, when we are talking about the McCall software quality model, this model talks about that this model is divided into three different parts. The first one is the operation of the product, the transition that comes when you are working on the product, and revision of the product due to the transition of it. So, let's understand first what product operation, revision and transition is. So, that talks about the correctness, efficiency, integrity, reliability, usability. Revision is when the factors that are required for the testing and the maintenance, those all are combined together. It is the product revision. There were some of the errors that were already found out, or the product is in the maintenance phase and then you need to make a changes into it, that is product revision. Transition is, it is moving into a transition phase where the project was or the product was working at one platform. Now it moved to another platform or maybe from one technology to another technology. Now let's again understand this model. As we have just seen that the product operation is something which talks about the operations on the system. So, the quality factors that we'll have will be the correctness, whether the operations are correctly done or not. Is it efficient enough to give you the expected output? Does it maintain the integrity of the system? Is it reliable and is it usable by the people of all sorts who are actually using that software? Product revision talks about whether the changes that you have made, maybe identifying the bugs or maintaining the software. So, the factors that we have are maintainability. Is it flexible enough that you are able to maintain it or change the features that you wanted? Or is it testable, whether the software is designed in such a manner that it can be tested properly? The product transition. The product transition is when you are moving the product from one technology to another technology or maybe from one platform to another platform. So, we talk about the portability over here, that you are porting the product from one platform to another platform. The reusability, the components that are already there in the system, can they be reused in the later stages? Interoperability, that means you can operate it on different platforms or different environments that are there available for your software. Now comes the software quality assurance. Now, when we talk about the SQA in terms of IEEE, the quality assurance process is a process for providing adequate assurance that the software products and processes in the project life cycle conform to their specified requirements and adhere to their established plans. So, this is the definition when we are talking about the assurance of the quality. We have some more definitions which say that SQA is a planned and the systematic pattern of all the actions that are necessary to provide adequate confidence that an item or the product conforms to establish the technical requirements. It is also the set of activities that are designed to evaluate the process by which the products are developed and manufactured. Now, the question is, why do we need such kind of plans? Because we want to ensure that the final product that is being produced is of high quality, because higher the quality of the product, more satisfied the customer would be. So, the final product produced is of high quality. Some quality control activities must be performed throughout the development of the software. So, this when we are talking about the quality assurance, we are not talking about the quality at the end of the software development. It is an ongoing process starting from gathering of the requirements till the deployment of your software. If it is not done, correcting errors in the final stage can be very expensive, especially if they originated in the early phases. So, we have the plan structure where we talk about the product introduction, the product plans, the process description, the quality goals, and the risk management. So, whenever we are talking about these plans, they should be very short in a documentation part, because if they are very long, then no one would read them. So, if we talk about the structure, the first one that we have is a product introduction, where it only gives us the proper introduction of your product, how the product works, what were the requirements, what are the platforms on which it is working, the hardware and the software requirements, everything that is there comes under the introduction of your product. Product plans talks about what are the plans you have thought of for the product in the future times. Process description, what is the process involved when you are working on this product. The process could be what are the roles of the developers, what are the roles of the testers, the management contribution, or what are the tools that are being used in the process of developing this product. What are the quality goals that we are talking about, on which the focus is there? If the SRS is there, if the SRS is made, what are the quality checks that it has to pass? All those things come under the quality goals. The last one, that is risk and the risk management, is very important. If suppose the product is not a qualitative product, what would be the risk? How much loss could be there? Do we need to, if we need to change the product as a whole, then what would be the risk? How do we manage that risk? How would we manage the resources? If the crash happens, what will happen up? So, all these things are the risk management. So, the scope of quality management. The quality management is particularly important for very large and complex systems. The quality documentation, it is a record of the progress and supports the continuity of the development as the development team changes. So, because we are working on large projects, this progress needs to be checked at every stage, because we have a high staff turnover in the IT sector. But when we talk about for smaller systems, they need less documentation and should focus on establishing a quality culture. The certain activities that are there in quality management, the quality assurance, quality planning, quality control. The assurance, quality assurance, that means establishing the organizational procedures and standards for the quality. If at the organizational level only it is identified that yes, these are the quality goals, then it is easy to implement. Quality planning, to select the applicable procedures and standards for particular project and modify them as required. Quality control, to ensure that the procedures and the standards are followed by the software development team. We have certain standards, the product standards and the process standards. So, when we talk about the product, they are related to the product as a whole, what are the component, their characteristics. So, product standards, they define the characteristics that all the components should exhibit, example, a common programming style. When we talk about the process standards, it defines how the software process should be enacted. So, the two approaches to quality control is again checking the software development process to ensure that the procedures and the standards are being followed. We have two approaches. The first one is the quality review and the other one is automated software assessment. We already have some automated tools to assess the software and to measure it. The next thing that comes is the verification and the validation. So, when we talk about verification, we say it asks you a question, are we building the product right? The product that is being given, is it correctly prepared or not? Validation says, are we building the right product? That means we are validating whether the requirements that the user gave, are we building the product as per the requirements? So, that is the difference between verification and validation. We have certain activities in the verification and the validation phase. In the requirement phase, the activities include the system requirement analysis, the software requirement analysis, the interface analysis, the process analysis, technical reviews and audit. When it comes to the design phase, it talks about the design analysis, test program analysis, supportability analysis, the technical reviews and audits that normally takes place at each and every level. Code phase, the code analysis, test program analysis, supportability analysis, again the reviews and the audits. Because at every review and audit, we validate, yes, the product is being made as per the user's requirement with these analysis, and at each and every stage, we are verifying whether this is being prepared as per the user's requirement or not. And at the end, when we are at the test phase, we validate, yes, that whatever the requirements that the user has given, we are working on the product in the same manner. So this is the criteria when we are talking about the risk. So verification and validation criteria is, it should mitigate the risk, it should consume that risk. Now risk is a product of the probability of the undesired event that can occur, and what are the consequences if that event occurs and how would your system behave. So it must be based, the V&V activity, that is the verification and validation, must be based on the risk probability and the consequences. And these are the benefits for the technical and the management team. When we talk about the technical team, it gives us the better software or system performance, higher confidence in the reliability, compliance between the specifications and the code, and criteria for program specification, where program acceptance, where the technical team gets a confidence that yes, the software is a qualitative software. For the management point of view, it gives us a better visibility into the development, better decision criteria, second source technical alternative in case one approach fails, what would be the another approach for a particular product. So these are some of the benefits that are there for the verification and the validation. So in today's video, we have basically focused on the software quality analysis, where we talk about that a qualitative software helps to gain the confidence of the customer, and it also increases the confidence of the development team. In that case, we work on the verification and the validation process, where at each and every phase of the software, we try to verify that the software is being built as per the user's demand, and we validate that the product that is being built is the right product or not. That's all for today. Thank you.